Good evening, and welcome to the next episode of FieroCast. On this episode, we look at the revolutionary technology that is the Fiero space frame and the tolerance of the body panels. I am your host, Mike Cryer, and you are listening to the newest episode of FieroCast, the only podcast dedicated to the Pontiac Fiero and the Fiero community. You can find past FieroCast episodes at FieroFocus.com or on our Facebook page at N.I.F.E Club. We'd like to thank our FieroCast supporters for this 2022 season: the Fiero Store, Rodney Dickman, Bontur Solutions, the Midwest Fiero Clubs, GoldenEye Graphic, and the N.I.F.E Store. Our one big supporter, the Fiero Store. We all know how hard it is to find those Fiero parts. We also know that as the years go by, finding parts isn't going to get any easier. The big box stores will never make new Fiero parts because our community is just too small. This is why we need to support the companies who support us. For nearly 30 years, the Fiero Store has sponsored our club events, provided free technical support, and produced well over 150 exclusive parts that no big box store would even consider. So, the next time you need parts, head on over to FieroStore.com and browse through thousands of products that are specifically designed for your Fiero. That's FieroStore.com, the world's largest source for Fiero parts. We also like to thank at this time Bontur Solutions. And at Bontur Solutions, if you are looking for that special personalized gift for someone, Bontur Solutions can help you find that one-of-a-kind gift. Anything from a t-shirt, a sweatshirt, drinkware, signs, decorative items, holiday items, and so much more. They can design pretty much anything you want, from pictures of your car, your favorite sports team, a pet, or any saying that you may want. The list is endless. Minimums are just one of each of any item, and the best thing is they do not charge a setup fee. You can catch Bontur Solutions at several Fiero and Pontiac events, including Fiorama, the Dells Run, the upcoming 40th anniversary of the Fiero, and the Indian Uprising All Pontiac Show in Crystal Lake. So, feel free to visit their website, give them a call. Phone number is 847-453-3291, or you can email Bonnie at bonnie@bontursolutions.com. All right, so let's get started and talk about this Fiero space frame. The idea of this geometric form that spreads tension and compression into several of its numbers is not new. This is technology and a concept that has been around in several aeronautical, nautical, architectural structures since the mid-1950s. The interlocking pyramid or half octagon roof structure found in McCormick Place in Chicago, Illinois, or large portable stages and lightning gantries have also used in their touring equipment and presentations are all examples of this revolutionary concept of a space frame or of a space. The idea that this design concept would eventually find its way into the automotive design industry was to be expected, just unknown when. The 1954 Mercedes-Benz 300 LS, which we all know as the Gullwing Coupe, was one of the earliest vehicles to use the space frame support. The weight of the unique door design that hinged upwards into the roof, which was key at that time. In 1960, the Lotus Type 18 and later Types 24 and 25, especially in the F1 race cars, used this space frame design as well. So the space frame used in the 1993 Audi A8 led the way for the later Audi TT Coupe, the TT Roadster, and the Lamborghini. Audi was awarded the European Inventor of the Year of 2008 for the Audi space frame, or the ASF technology. There's many examples of the space frames that have been around. Some of the other examples of automotive design that have used the space frame are the Ferrari Modena, the Scaglide, and the 559 GTB models. The most recent is the Ford GT40, and the newest is the Rolls-Royce Phantom, which represents the largest automotive space frame ever made. And the Mercedes built their smart car, which is the smallest to use as space frames. But GM, or General Motors, use space frame technology in all of the purpose vans, the APV minivans from 90 to 96, and the Saturn vehicles from 91 to 2007. In 2006, the Diana Corp began supplying components to General Motors to be used on an ultra lightweight space frame for the new special edition Z06 Corvette. This full-length side rails that are major components of this frame are hydroformed in Pontiac, Michigan. What a coincidence. The first space frame on which ever worked or came from Pontiac, Michigan, and was used in the Pontiac Fiero. So, with all that, heading back into 1984, when the Chevy Corvette was still using the Premier type frame or perimeter type frame, which had been used for many years, it was now the Pontiac Fiero that introduced the revolutionary space frame to the U.S. production vehicles. And over the next 4 years, the space frame technology was the basis of all Fiero production vehicles. So, to clarify one point, the space frame is not the same as a single shell or unibody, which is used in most of today's production vehicles. A unibody uses welded metal outer skins, such as the rear quarter panels and the roof, for strength, rigidity, as well as subframes to form the vehicle's unique structure. But the Fiero space frame is a self-contained, crash-tested, high-strength steel structure to which composite plastic panels that are not part of the structure are then attached to it. So all of today's race cars use a similar design and the lightweight body over the cage or frame to protect the driver in the case of an accident. So the inherent safety of the space frame structure is part of a major feature. But another important aspect is called fit and function. And you're probably looking or asking, what is fit and function? For years, the doors, the fenders, the hood, and the trunk lid fitments were assembly line problems. So even with the combining of all the components in front of the windshield, such as the fenders, the hood, the wheel housings, and grille, an assembly called what they call the doghouse, aligning that substructure with the roof, doors, and quarter panels of the unibody design was still very difficult and very time consuming. So, with the Fiero space frame, that solved all of those problems. During the space frame assembly, almost 4,000 individual welds, each with its own tolerance, are required. In the final assembly process of the front and rear sections, they are matted to be compartment to the compartment floor. Pretty interesting, and it's the various types of the plastic skins that cover the space frames that are aligned in a single marching or machining pattern, and during the operation, which we now know is the mill and drill. 39 individual resin core pucks have been welded onto the space frame during its creation. And if you're online, just Google the mill and drill, and you can even see pictures of the mill and drill machine in the Enthusiast Guide to the Pontiac Fiero. And this machine just is awe-inspiring. And I would have loved to seen how this thing worked in person back as they were making the Fiero. But that was a very impressive machine. But so going back to the space frame, all those mounted on the assembly line dolly and moves into the enormous machine that, again, we know as the mill and drill. In one single downward stroke, the mills, the height, and the drills are attached in all 39 pucks simultaneously. Again, to see that in person would have been really something. To just see the frame go up the rail and all 39 pucks get welded simultaneously together. A master gauge point located in the door sills guarantees corrected positioning of the frame in the mill and drill process. And the panel assembly now occurs with only the gap adjustment required, resulting in a much better body panel tolerance. Again, just to see this machine work. But it does bring up a good point on the panel assembly and how it adjusted the gap and the gap adjustments required, resulting in a better body panel tolerance. You're probably asking, what do you mean a better body panel tolerance? Well, if you go out and look at your Fiero and you look at the lines of the Fiero, and specifically either the front passenger driver's side fenders and your hood, or even your deck lid and your back quarter panels, look at that line of going from the front fascia to the windshield. That is where you're going to see your gap tolerance. And if your hood is misaligned, then you're going to see that gap go from, it could range anywhere from 1/8 of an inch to 1/4 of an inch coming up from that fascia to that front window. But if your hood or your deck lid is misaligned, it's going to become tighter on one side versus the other. And I'm just thinking back on when I had played around with switching my hoods out and keeping my original hood on. It's very hard to get that realigned once it's off and you put it back on. So looking at my tolerance on both sides is completely shifted now because I've taken off my hood. And I was okay with that. But then when I redid my headlights to the low profile buckets, I had to take that hood off again because that's the only way to get into the front headlight area to get that put together. And when I put my hood back on, the gap became extremely tight on the upper passenger side to where it's not tight enough to break or for the paint to rub, but it is extremely tight to where on the driver's side I do have a larger than 1/4 inch gap, which drives me crazy sometimes, but it's very hard to adjust, and I'm still trying to play around with that. But that brings us into what is tolerance for tolerance. So as time progresses, most aspects of the automobile have improved over time. Where we once had to hand crank an automobile to start the engine, we now have an electric starter. Where we once had to adjust the fuel mixture manually, we now have cars with computers that automatically adjust the fuel mixture for optimum operation under various and changing conditions. Where our cars once have had relatively weak manual brakes at the rear wheels only, we now have power assisted anti-lock disc brakes on all four wheels. And where we once had to stop often to replenish our drinks, our cars now have cup holders that can accommodate up to a 64-ounce beverage. Okay, so maybe that last one is not as an improvement or important. Nonetheless, generally, cars have improved over the many years. And especially now going from an electric or an engine that runs on antifreeze and oil and gas, we now are in the electric age where you just plug the car in and it runs on battery. Just like those old RC cars that, we still operate, or, anything that requires batteries. Now our daily driver cars are operating on those types of batteries. So improvement, yes, but it also has been a factor in the car's construction. But the improvement has not always been linear. And in most cases of car body tolerances, actually has become worse over a period before continuing on the course of positive advancements. In the early days of car construction, extending it into the early 1930s, the body parts consisted of hand-formed steel, fabricated with specialized tools by skilled craftsmen that were often attached to wood frames. And in the late 20s, early 30s, car bodies were beginning to be completely fabricated of steel with no wood framework. Stamped steel pieces were welded together, and that method of stamping relatively thick steel sheet stock improved the consistency and quality of those pieces. This allowed the panels to fit on the car frames more accurately, although the dies used for the stamping process did wear, contributing to decreased accuracy of the parts manufactured later on in life of the cycle of the dies. So additionally, most of the parts, despite being built on an early assembly line, the cars were still technically hand built in that the body panels were shimmed and adjusted to fit well. If you purchased a car very early on for that, we'll say, model year, your tolerance on body panels was going to be damn near perfect. But if you waited to the later part and you purchased that exact same car, you may see that tolerance of body panels being a little bit more of a gap. So now you have an assembly line that will give you that every single time, no matter when that car comes off the assembly line. So in the latter part of the 1920s, the automobile manufacturers discovered that style sells cars. Always will, always has. And all that, although it wasn't immediate, form took precedence over function. And this trend, which culminated in the 1950s, continued into the 70s as well. Although specific information relative to the design intent relative to the car body tolerance from the 1930s to the present is not readily available, so it was a little hard to determine. But it is generally believed that the body panel gaps become smaller and more accurate into the 1960s, and then became worse leading up into the 1990s. Improvements that occurred with this aspect of car body fabrication and construction were minor, and the progress was always slow. So, the progression and eventually reduction of the quality occurred because of the many factors affecting the design and construction of the cars, such as the manufacturer's desire to produce as many cars as possible in that given year or time frame in the shortest period of time and the highest possible profit, using a workforce in tiers of suppliers competing for the manufacturer's business by producing the lowest cost parts. And let's face it, you generally get what you pay for. So if you buy a base model at $10,000 versus a fully loaded at, say, $60,000, your car will probably not make it to 100,000 miles versus maybe 150 on the 60,000. So consumers who, for the most part, did not care that much about quality. They just wanted to get the car, and they wanted the desire and the latest product that came out of, we'll say, Detroit, because that's where most of the cars at the time came from. And they wanted it to be different from last year's model. This may be an oversimplification of what had occurred, but it wasn't until Dr. W. Edwards Deming showed the Japanese manufacturers how to really improve quality, and the domestic manufacturers saw an erosion of their market share that all automobile manufacturers addressed through the car body quality. And with Dr. Edward Deming was an American statistician who had developed methods, including the application of statistics and improving design, productivity, testing, and sales. And he was also an influence for assisting Japanese corporations after World War II, and later assisted Ford in improving their quality as well. But it is also quite evident that most all of the expensive cars in the luxury segment receive more attention to the body quality than, we'll say, the lower end price cars. Again, you look at a Geo Metro versus a Rolls Royce. Your body style and body tolerance panels are going to be 20 times, 100 times better on that Rolls Royce than the little Geo Metro. So you kind of get what I'm seeing on that one is they cared about the higher end. So let's pay more attention to the Corvette than our little Chevy Sonic, we'll say, So anyways, so going back on topic here. Going back to the winter of '78, after Pontiac had got its first approval from the former Pontiac chief engineer and then GM president, Elliot Pete Estes, to continue to study the concept of the Fiero, bringing in Halke, chief of advanced engineering for Pontiac, had announced that he was very interested in making sure that the customer satisfaction, fit, finish, and quality were the highest possible. In addition to the unique manufacturing technologies, Halke realized that the process would require new manufacturing mindset. So, based on Halke's vision of an entirely new build process to produce the highest quality Fiero possible, the team incorporated statistically quality control, processing following the methods developed by Dr. Denning. In terms of the Fiero, various aspects of the car were evaluated during the build process so that the problems could be corrected before the car even advanced to the next step of the construction. The Fiero was to be built in a very small plant, but with the highest quality of that luxury car rolling off the line. And unlike other car manufacturing plants, there was nowhere to park cars that needed to be repaired after the construction was complete. These Fieros, once they hit that end of that assembly line and ready to go out those doors, you were driving that luxury car. This car was to be the best as it exited that garage door as it came up. By starting this idea of high quality and in integrating the process into the assembly, everyone involved was forced to build the cars correctly. And you watched out for somebody who was having issues and you worked with them. And everybody building the Fiero was held accountable for the quality of each of their positions on the line. And each had every drop, tear, blood into those cars to make sure that they were the best as it passed through their manufacturing assembly plant line. And the way Halke and his people hoped to get that quality was to do a totally different body build. A completely new way to put together the body. So it would be hands-off in terms of panel fits. No leaded seams, no exposed body joints, and no Monday morning slip-ups. Halke and the design engineer, Edward Falderido, I know I got that wrong, came up with a new revolutionary idea in vehicle construction. They decided to borrow from the race car practice and make their car with a full space frame. Its structure completely independent of its own outer body panels. And the inner metal frame would carry the exterior plastic panels, and the body skins would be fastened to a quick mount system that controlled surface seams and held alignment to within a thousandths of an inch. It would be also plastic panels that would allow for tighter tolerances as well. So the steel distorts from the heat. The Fiero space frame was made up to 273 separate pieces held together by 4,300 welds. The heat alone, the heat from which resulted in the slight buckling, bowing, and deflection of the individual steel panels. The plastic panels, however, came out of the molds with accurate dimensions and tolerances, and without any spring back like the steel panels would give. And what is spring back? Well, spring back occurs in the metal panels because of the flat sheet of steel. It wants to remain flat. So when the dies force it into a new shape, the panel attempts to return to its flat configuration. And the steel panels must therefore be slightly overformed so that they can achieve that actual desired shape after spring back. And the plastic Fiero body panels leave the molds dead accurate. So the team quickly realized that you cannot take an accurate part and made it to an inaccurate part. So the space frames would need to be machined to net the differences in the tolerance. Bringing a part to its final dimension through machining that was not really a new concept. So the project engineers realized that if they could machine the points of contact between the steel space frame and the plastic body panels, they could achieve a perfect body fit. This is where the mill and drill machine comes into play. The mill and drill machine, of which there were only two in existence, was designed specifically for the Fiero. And the machine would accurately mill and drill 39 fastener holes for the body panels and the attachment points that were located on the space frame. This method allowed the attachment points to be uniform on every Fiero, no matter what had occurred in the space frame relative to the welding heat induced buckling, the bowing, or the deflection. This process, which GM patented, was never before utilized in fitting body panels on cars. If you're new to the Fiero community, you may not really realize that you can take GT body panels and put them on a coupe or a notchback, or take an Indy nose and put it on an 84 fascia, flip the fascias. You can interchange almost any body panel on the Fiero because, again, all the 39 points, all the body panel attachment points were located in the exact same spot on every Fiero. Prove us wrong. I guarantee you will not find one that is off. Another aspect of achieving superior body panel fit on the Fiero was the separation of form and function. Typically in automobile construction, a part like a door, hood, deck lid may function properly, but not fit properly in relation to the surrounding body panels. When adjusted to fit properly, the components may not function properly. Very confusing. But the Fiero separates these concerns because the body panels are nothing more than just a skin covering the steel components. The body panels are not part of the car's structure. The doors, the hood, deck lid, headlights can be made to function properly, and the body panels added later, fitting properly despite the position of any underlying steel components. Some may remember, some may not remember. Going back, 15, maybe 15 years, no more. The N.I.F.E. participated in the World of Wheels. And one year we decided to show a naked Fiero. And what we mean by naked Fiero was just exactly what I just talked about. Everything, the whole skin was removed from the car. We cleaned up the space frame, we cleaned up all the hinges, all the components to make this naked Fiero look like it had just rolled off the assembly line with no body panels. It was a drivable, functioning car. Everything on it still operated as is, with just no body panels. So if you can, we'll have to dig them up, but if you can dig up the old photos, again, the Naked Fiero was an awesome project to work on because you got to see and understand what is under the Fiero skin. I know there's one or two out there that a couple people have done as well that are, again, are fully functional driving cars, just no body panels. So one additional variation in the methods used to produce the Fiero was single sourcing parts. Typically, GM would avoid single sourcing parts because suppliers to compete with one another for the work. However, single sourcing was the benefit of reducing variability and increasing accountability for quality. Since there was no additional supplier bidding fair and equitable part prices which were established. So a supplier who feels that they negotiate a fair price for their parts is less likely to try to cut corners and produce an inferior part. All of these endeavors ensured that the plastic panels aligned with a tolerance of 1/64th of an inch, 0.015 inches or 0.38 millimeters. This was a very ambitious goal in the late 1970s, and according to paperworks of CONSAD Research, the Corporation for the National Institute of Standards and Technology back in 97, they classified as the world-class standard was 2.0 millimeters. In 97, most plants in Japan and the U.S. manufacturing Japanese automobiles were meeting that 2.0 millimeter tolerance. But at that time, only 5 domestic manufacturing plants could meet this goal. A paper prepared in 2000 by Auto Steel Partnerships Program indicates that body panel tolerance meeting the 30% repeatability and reproducibility rule had tolerances of plus or minus 0.75 millimeters for non-rigid panels and plus or minus 0.5 millimeters for rigid panels. This was still approximately 100% and 76% less accurate than the goal set by Halke for the Fiero, some 20 years after the Fiero was first conceived. So, for the purpose of tolerances, we compared the tolerances of the body panels of a stock 1985 Fiero, of which the owner is the original owner and can attest that the body has never been damaged, removed, or modified, and found that the tolerances of the panel gaps do meet the 0.38 millimeter goal. We also compared the body panel gaps of a Fiero to a steel body of a 2003 vehicle and a 2011 vehicle and found that the gaps between the Fiero and the 2003 vehicle were very comparable. But the comparison with the 2011 vehicle indicated that the body panel gaps of that vehicle were approximately 25 to 50% smaller. Then compared the body panel gaps of the Fiero to a 01 Saturn, a GM car that also had a space frame and plastic skin, and found that the body panel gaps of the Saturn were in some instances larger than those of the Fiero, and in other instances smaller. So what was the obvious in inspecting the Saturn panel gaps was that the tolerance of the panel gaps were not as tightly maintained as those of the Fiero. At the Saturn's hood, the gap on the driver's side was 1/8 of an inch wide, and the leading edge was 1/4 of an inch at the trailing edge. The opposite hood gap ranged from 1/8 of an inch at the leading edge to 5/32 of an inch at the trailing edge. Then we jump to the deck lid gaps, were very similar, non-informed. The real surprise was the door gaps, which generally were about 5/16 wide and varied by, plus a 32nd to a negative 16th of an inch. The difference in maintaining the body tolerances between the Fiero and the similarity constructed Saturn is likely the use of the mill and drill process used for the Fiero. Everything was consistent across the board. All the same rivet spots or the puck spots were exactly the same. There was no difference. It had a spot in each one exactly the same. So it's generally safe to characterize that the body panel gaps and tolerances of today's cars are being smaller and more accurate than the early vehicles. But, however, it took most of the automobile industry more than 20 years to best the body quality of the Fiero relative to the body panel gaps, width, and uniformity. We can say that the Fiero team set an ambitious goal for body quality, and for the most part, they met that goal. A feat that most have seemed ridiculous when first proposed in light of the current technology, but they accomplished it. This through a unique attitude towards quality and innovative concepts as to how such quality can be achieved to give you the best car that ever rolled off that assembly line. And why cars like the Saturn did not have the same quality cannot be answered without further research. But needless to say, the body panel quality is yet another aspect of the Fiero that was well ahead of its time. And when it rolled off the assembly line, you were driving away in that luxury, perfect vehicle. I bet you are all going to go out and look at your Fieros now and see what the tolerance of your gaps are. And I will tell you that unless it's been into an accident, the body panels have been removed, they will all be the same. And it's that quality that rolled off the assembly line almost 30, 40 years ago with your cars. So it's a test. Go check. And if you're like me and you removed your hood or your deck lid, your tolerance level will be off, just like mine. But if you have a Fiero that's never been touched, I guarantee all those tolerance body gaps are going to be exactly the same, all sides. And if you have a Fiero next to you, they're going to be the same. And if there's another Fiero next to you, they're going to be the same. So I hope you were able to learn more about the space frame technology, the mill and drill, and the tolerance levels of the Fiero body tonight. It's very interesting, and I wish that we could talk to somebody that worked the mill and drill machine, just to get, or worked by it, just to see and from their perspective of how that massive machine worked. So maybe that'll be a future podcast if we can find somebody. So needless to say, very awesome technology, and you're not going to look at your Fiero the same if your tolerance gaps are off, because you're going to question, why is my tolerance gap off? So, all right. This podcast was written by Gary Watson and Christopher Sass, as well as myself, Mike Croyer, and is a production of the Northern Illinois Fiero Enthusiasts. I thank you again for joining me tonight. I am your host, Mike Croyer, and thank you for listening to the newest episode of FieroCast. This is episode 27, and it is the only podcast dedicated to the Pontiac Fiero and the Fiero community. If you'd like more information or have any future ideas for FieroCast, you can email me at mcroyer, Kroyer, at FieroCast.com. Remember to keep Fieroing, and good night, Fiero owners, wherever you are.